welcome.
This meeting is being recorded.
Welcome to the Stanislaus Green Team. We appreciate you showing up. My name is Lyndon Coffey. I'm co-chair of the Stanislaus Green Team. We meet here on the third Thursday of every month. We have one more meeting after this in November, and then we take December off. So keep that in mind. We normally do introductions. We can do that really quick, I guess. As I said, I'm Lyndon Coffey with American Recycling. We'll take it around the room real quick. Trish.
Hi, Trish Christensen, President and CEO of the Modesto Chamber of Commerce. Jolene.
And my name is Jolene. I am the Sustainability Coordinator for the Modesto Chamber of Commerce.
Thank you.
And I'll introduce Kirk in a second. Just an FYI, our next meeting will be November 17th. Again, that's the last one of the year. I'm going to turn it over to Kirk Oatman. He's the co-founder of I'm in Control. Welcome, Kirk. Thank you.
Thank you for having me. We can make this just a very informal discussion today. Please interrupt any time. The objective is a couple of things. A, to give you hope that you actually can do something with your, as we say, not huge buildings to reduce energy usage. And the other is to give you some specific approaches to use to accomplish that. So if these are some of the buildings we'll look at, right? We're going to look at them. We're going to give you kind of what happened in them and give you a sense of how buildings operate. On the whole, again, like we say, not huge buildings because those have large, expensive control systems in them. These are the buildings that you go to work in every day, that you go to buy things in, that your kids go to school in. And so that's the focus that we're at. And those buildings have historically had almost no attention from a controlled viewpoint for energy. So now this building, this is a historic courthouse, about 80,000 square feet. That's an outlier for us, but it's exactly right. It kind of illustrates a lot of the things that we do because we have to control the exhibit areas carefully for the historic pieces. They can't have too much sudden temperature change, for example. They have huge events in there, 200-300 people that are walking all around the museum, having meetings in the old courtroom. And so the person who runs those meetings is literally controlling the heating and air conditioning in the building minute by minute. Maybe she's at home and they call and say, oh, it's getting too warm, such and so. I mean, literally, this is something that just doesn't happen with the control systems that we know about for large buildings. So we're going to kind of step through. That was some of the points that I was making. So small modular buildings in a campus setting like schools, that's a really important place to add new types of control that the large old systems simply don't handle. The smaller buildings don't have an existing what's called building management system running them, right? And the ones that run the large buildings are just gigantic, huge, expensive, difficult to use. Normal human beings, like all of us, do not have access to those control systems. And obviously, but if you think about it, it has importance. The big buildings have one or more engineers literally sitting in the building, paying attention to the building, minute by minute sometimes. And I mean, a 10,000 square foot building that has offices in it, you don't have somebody sitting there that knows anything about heating and air conditioning. So that means that a system has to be easy for the occupants to use, which again, that's not true in the large buildings. And of course, the equipment is very, very different. You've seen pictures of the equipment on the roof of large buildings, lots of pipes, big blowers and everything like that. That's not what smaller buildings have. And then obviously the costs are completely different. A smaller building might be $30,000 to $80,000 a year in energy, and a big one can be, 10, 20 times that, of course. So the cost of a project to put control in has to be relative to that amount of money that you can save on the energy. So let's start with an interesting building that illustrates a number of the points. This is about a 20,000 square foot medical services building. And this gives you an idea of what they look like from the roof. These are units that are about this big on the roof. Each one of them has big ducts going down to a particular zone with a thermostat there. When we went into this building, and let me tell you, you'll chuckle as I talk about this, but this is really amazingly typical of a lot of buildings because nobody has been thinking about the energy in it. So when we went in, we did a period of just monitoring before we took control. And we found for the heating and air conditioning, literally 57% of it was wasted. Wow. And I mean, this is not unusual. We couldn't tell with the receptacles whether it was valid or not, but the interior lighting, almost half of it really was wasted. The exterior lighting, at least a quarter of it was wasted. 64% of the energy for exhaust fans was wasted. So now, what does this lead to that you can do about it? The first is, so of those, we identified 15% that we could reduce by automation of the thermostats, optimization, and all that. And another 22% of things that they could do, not even with our system, that we can talk about today. And it ended up with 26%. So they did about half of the things that we recommended. Okay, so this is the whole part. There is something you can do about these buildings. So first of all, I talk about thermostats. A system like ours, and yes, there are other systems that are smaller that are similar as ours. I won't say they're as good, but that you can also consider for a building. We take control of the thermostat, we replace it. We then know who's in the building when. We bring up a room or an area just in time in the morning. So maybe sometimes it's only 15 minutes before people get there. Sometimes maybe it's 2 or 3 hours. Say it's a Monday morning on a cold winter day and everything's been off all weekend. That takes 2 or 3 hours to bring it up to temperature. But if it's mild springtime, 15 minutes kind of refresh there and that's enough. These are not insignificant changes to energy usage. For the interior lighting, for large areas, just use some occupancy sensors. They don't even have to be connected to a system like ours, although they can be. The exterior lighting, this was interesting, and this is the kind of thing you can look at for a building that you're thinking about here. They have to have, because actually it's a county-owned building, they have to have the parking lot lights on when it's dark. But they also had these soffit lights on essentially all the time as well. And all they really needed those on was when people were coming in and out when it was dark. So what did they do? They had timers on the parking lot lights. And so all year, the parking lot lights came on at the earliest time during the year that they would be needed, which is like 4 or 4:30.
Yeah.
All year. Summer, not till 8:30 is really necessary. And so literally all they did was put on detectors to say, turn on when it gets dark. I mean, they pulled down that full 25% just like that. A trivial project. The exhaust fans, they put occupancy sensors in the bathrooms in one of the zones, and they saved all that energy. So you don't have to have a system like ours to do it. I'll keep talking to show why it's helpful, but you just have to think about it. Somebody has to be paying attention to it. So let's see if we can, just a minute. I'm sorry. I'm looking for, there we go. We're actually going to visit a real building. This is a building. This is a view, this is a smaller building. This is a senior center. It has 5 zones. And I'm not going to go into all the details, but basically, look, these are the set points. That's the current air temperature. It's telling what they're doing. And then we can find out what's going on. If we look, and this is live, this is actually right now happening. So the dining area, well, overnight, I don't know if you can read these numbers, it got down to about 66 degrees. The system turned on, it started warming up, it warmed up here. And now pretty soon, this being the cool and the heat set point, pretty soon it's going to kick on air conditioning. And something is not showing here. So let's see if we can look at, for instance, yesterday, and now it's showing exactly what happens. This just means the thermostat said, give me air conditioning. So look, you're already becoming an expert in HVAC just by looking at this. And I'm serious, people actually use this in buildings. And you notice when it calls for air conditioning, the temperature comes down immediately. And I'm going to show you something else that's really kind of amazing. So if we're monitoring the electric usage for that very unit, this is the number of watts. So when it calls for air conditioning, it's using 16,000 watts and it drops. And all of this makes sense, right? I'm going to show you later how all this ties together to not only like optimize the building, but we can tell when something goes wrong. And that is a huge thing to be able to A, get a repair done more quickly, and B, they know what they're walking into when they get to the building because they already have this information, the text. So it's surprisingly useful. Now, if we really look at the building as a whole, in fact, let's look at yesterday so we get a whole day, okay? Let's see. Oh. Look, you actually are seeing a building breathing electrically. I mean, that's literally what's happening. And just maybe if I scroll up a little bit, we see that in this particular building yesterday, people came in around 8 o'clock, the office people did. They didn't start having events and things happening until 12:30 or 1. They had people there doing things until 8 o'clock at night, and then they started shutting everything off. And let's get even more down into the weeds. And I'm doing this, I'm getting awfully technical, but each one of these pieces of information gives you help in finding out how to reduce the energy in that building. This is only the HVAC, and you see when it's being used. I'll show you, say, only the lighting. And of course, this is the key that I was saying at that other building. We saw that it was using too much at night, more than it made sense. And indeed, yeah, you have, this is 500 watts, so you have 100 watts running at 7 a.m. So people came in and turned on lights of various types. At 8 p.m., a lot got turned off. So just think how you can use this in your building to say, what's happening? When is it happening? Why is it happening? Why are we spending this money? And so it's really exciting stuff. And quite frankly, we tend to geek out on it because it's really fascinating and educational. So to give you a sense of what happens, what goes into a building for a control system like this. The very first thing, very simple, a controller that's in the building itself to provide high reliability. We're not going to the cloud because sometimes the connections crap out, right? So there's a separate controller in the building. We install a completely independent, separate wireless network. It has nothing to do with the data in the building. You have no chances of some intrusion or something happening. It's our wireless system entirely. And then, like we said, we just replaced the thermostats. We take the ones off the wall, frankly, you've got them right here in the building, exactly those thermostats. We take them off, we put on ours, they talk to us by this wireless network. We add some monitoring of the electric usage. Basically, this is a breaker box. There's a box that goes beside it with some little wires and things on each breaker. And we are looking at the electric usage every 15 seconds.
Oh, wow.
We get like 1 million data points a day for just, a 10, 15,000 square foot building. This is why we can say when we apply artificial intelligence processing to it, we have the data to actually do something useful with. You've got to have data before you can use AI sensibly. Now, if you want to get really fancy and add a lot of capabilities, of course you can do that. You can add occupancy sensors so you know when somebody is in a particular area. Water leaks, big risk for a building. Don't happen very often, but when they do, they can easily be $10,000, $20,000 to repair if they haven't been found right away. New things, CO2 monitoring, big thing in schools now. In fact, California has a program that is giving free CO2 sensors for every classroom in a school, if you apply for it. You got to apply by the end of October, so get on it. Air quality in general is A, useful to know, and B, some companies would want to have that information either for their employees or their customers. Yeah, you can control lights, you can control other kinds of heavy duty equipment if you want to. Each one of those will save you some energy. Obviously, it talks outward, and you just saw us accessing a building in a different city in real time. And obviously, we talked to all sorts of utility programs and so forth that I'll talk about in a minute. So here's the building that might look a little bit more like you, the listener, knows in this area. This is a 45,000 square foot building. It's a combination of, there's administration offices, there's a big R&D section. They have clean rooms here. Now, talk about really needing to pay attention and get things right. Those clean rooms are on a very short fuse for anything going wrong. Big assembly and manufacturing areas, big warehouse, huge machine shop. So for that, each area has very, very different requirements. And like I say, for the clean rooms, high accuracy stuff. Here's another interesting thing. A year ago, our system detected on a Sunday morning that all the power went off in the building. We knew we were still talking to it, but all the power went off. Nobody was in the building. So we immediately notified the people there. And what happened was they could get there, they shut off machinery that needed to be handled correctly. The building, just like them next door that did similar work, they had highly expensive repairs to two of the pieces of equipment because they didn't know about it, they didn't do anything about it. So you never know kind of what you'll discover is going on. So I said, why do we watch the electric usage? Well, we can detect faults, and I'm just going to show you very quickly. Look, this is one of the clean rooms, and remember, this is the electric usage. It's going on and off, and then here was calling for air conditioning, and it's working. Suddenly, look, the next day, we said, oh, you need air conditioning, it's calling for it continuously. The compressor went on here, and then suddenly it goes off. The fan stays on, but the compressor just goes off. And so we could notify them, and within like a couple of hours of this notification, they had somebody there fixing it. So I mean, almost always we find a fault before people even know that it happens. Okay, here's an interesting one. This is a city in the Bay Area. This is their council chambers and their offices along both sides and in that 4-wide modular. So here's what we saw. This is the electric cost the year before we went in. This is the electric cost the year after and the year after that. You know, about 22% less. Now you notice also though, it's different by month. Those are useful pieces of information. I won't go into detail, but when you look at these kinds of things, you can tell what's happening and why. Okay. Here's an elementary school. This is really a very, very important place for control systems to be, because the units on modulars, this is a modular, this is 2 modulars. I think those are permanent buildings. Those air conditioning and heating units that kind of hang off the end of a modular building are incredibly inefficient, incredibly so. So controlling them the best you can while keeping the kids and teachers comfortable is really, really important. And what we did was, yeah, we achieved, 19, 20, 21% reduction. And the important thing it's been a big thing in the energy efficiency world for a long time. Oh, you put something in and then a year later, it's not saving anything because people aren't using it, people forgot about it. With a fully automated system, look, the year before, just absolutely consistent remaining energy loss, right? So that's really important. And I think this is the one. I couldn't help it. Every time I drive into Modesto on 132 coming east, I drive past what we found out was Franklin Elementary. And if you look, the red circle is every one of those very inefficient. I mean, you have to have them, but very inefficient units on the modular units in that school. And when you look at this, we counted, and there are probably 30 to 40 actual individual units at this school. Now, they may have a control system, but this is a perfect example for a place to look for energy savings with a straightforward control system. This is another approach. It's a police training center. There are about 20 buildings. It's a combination, again, of modular buildings, permanent buildings, gyms, administration, workout areas, lecture halls. Every single one of those has a completely different requirement for usage. And a lot of those spaces are used occasionally. So you don't want to run it all the time, but somebody has to have control to be able to pop it on when there is someone there. And when we sold this one, we kind of wanted to amaze them. So this is literally the month before we took control. This is the month after. Just look at it. From that to that. I mean, boom. This was with no effort on their part at all. It was just our system figuring things out and doing things right, which took it from 714 kilowatt hours every day to 570. There is hope for these buildings, seriously. And here's another kind of fault. And again, I'm not trying to get too detailed on you, But just to show you, it's not difficult when you have the right information to do things which are really useful and save money and comfort and all that. This is, again, a unit, you know, it calls for AC, it uses electricity, the temperature comes down. Look at this day. Boom, 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 it's calling for cool all the time, but the power is going on and off, on and off, on and off, but at a cycle every 50 minutes. You look at that, and there are sensors in these units, and there are retry timers that it says, oh, something happened. And so I shut down for a while and then I retry in 30 or 40 or 50 minutes. It's just absolutely obvious. When the tech goes, he knows that that's what he has to look for. Yeah. I mean, people don't think about that. I never thought about it before I got into this business, right? So I'm not going to go into detail about financing, but it's really important because we as a company aim at shorter than a 2-year simple payback for installations. And so you can make that even shorter by, there are a lot of financing options for these buildings, all right? Not huge buildings, but for these buildings. Just some examples are, I mean, one is on-bill financing from the utility itself. Now, is it PG&E here or Modesto, what is it, MID?
MID, yeah.
MID.
Different parts.
It depends on what, where you live.
Okay, I don't know about MID, what their policies are, but I'm sure that they offer on-bill financing. So you just give PG&E the paperwork that you did something, they split it out over N years. Sometimes it's a lot of years, and then you just pay every month on the bill. It's 0% financing. 0%. Now, there's a program out of the California Treasurer's Office called Go Green, and you can just get Go Green financing. This is a surprisingly well put together program where the application process is simple. Systems like ours, because we were involved in advising them, are just on the list. If you put it in our system, you can include it under Go Green financing. Right? And it's the loans are by private lenders, but it's guaranteed by California. So that means that the rates can be much lower than you would get through normal commercial financing. And then there are very specific programs for schools, cities, and counties. I mentioned one of those for schools. And there are other utility, state, and city programs. There are rebate programs where they'll pay between 20 and 70% of a project. Some of it is all upfront, some of it is half upfront and half after a year if you actually accomplish what you said you would. And there are many sources for free audits for your building. MID specifically does have that. PG&E does have it. You just request an audit, somebody will come in and give you some input. Now, I'm going to go very quickly through some interesting rate programs. Now, demand response is those times in the summer when you hear them saying, oh my gosh, it's so hot. The state is going to use lots of energy. And so please cut back if you can. So there are demand response programs that for those times utilize digital signal coming into a system like ours. And then when we have your building respond automatically to it, according to the way you set it up, you get paid for it. And so they're 4 to 5 hours typically. It's normally between 4 and 9 or 4 and 7 p.m. There are only like 6 events a month, and it's all automatic. You don't have to do anything. You can opt out if you need to for any given one. So that's a standard demand response program. This is a new set of programs that have been brought into California, administered by the utilities, let's see, there's a private company called Recurve that actually does the technology work for it. And what is called Market Access Program, it's just a continuous program. There's no specific event. Just save as much as you can when you can. You don't have to drop anything. You don't sign up for anything. You just sign up for the program. You get paid every quarter. And here's the key. This is what the state and the utility gets out of it. You don't get very much for every kilowatt that you drop during an hour. During most, January to May, the winter and so forth, you get paid 2 cents a kilowatt. I mean, if you did a whole bunch, that's useful. But then you get into the hot summer months, and you can get, depending on what time of day, what month it is, you can get up to 30 cents a kilowatt paid to you for what you reduced. And so when you think your average cost of a kilowatt hour is between 15 and 22 cents, this is pretty interesting. Not only are you not spending that money, but you're getting paid that money. And then this is a very interesting one that has come up just recently. Basically, just sign up for it. It's 10 minutes to sign up for it. There's no penalty, there's nothing, there's no commitment or anything, but on those super hot days, you'll get paid $2 a kilowatt that you drop.
Wow.
One of our city customers literally shut down an entire office building for 2 of those recent days when it was just incredibly miserable. And I don't know how much they got paid, but that was a lot of money because they honestly, truly dropped probably between 30 and 50 kilowatts.
Wow.
So this is a fascinating program with literally no risk, no pain. And so just a reminder for a system like this, how am I doing on time? Just about finished.
Okay.
You can start simple, just replace the thermostats. And we'll optimize it, we'll get it just in time, et cetera, et cetera. If you monitor just the electric usage of the HVAC units, we, or a system like ours, can provide you with fault analysis. Even when a unit is old, we can tell you how much that unit on the roof is using every year. You can compare that to what it will cost to replace it. And you can actually cost justify or not that replacement, which you'll absolutely get some rebate dollars for besides.
True.
So it's pretty interesting to have that information. Now, then you can start signing up for rebate and reduced rate plans, demand response, etc. You can add air quality or CO2. Again, particularly for schools and public spaces. You can do that detailed electric monitoring for the whole building, like I showed you, so you know it's lighting, it's plugs, it's whatever that's costing all that money. You can add control of, like I said, lighting, heavy equipment, leaks. Here's a pretty interesting one. One of our customers is a police station. Well, a couple of years ago, before we went in, the freezer where they keep evidence of crimes, the freezer stopped working. And they didn't know it for some amount of time. And so, I mean, we have a monitor in there, we have alarms set on it. I mean, there's no worry now that is not going to damage any evidence. That's a pretty specific application.
Sure.
But this is the kind of stuff that comes up. And then really moving into looking at all of this from the broad sustainability viewpoint. So, I mean, that's why we're here today, right? The Green Team. And, I mean, you hear from them about the Green Business Network and certifying yourself. Now, they also have rebates and specific programs for you to sign up for. So they're a really, really valuable resource, particularly for smaller businesses. When we talk about a small building, it may be part of a very large corporation or very large city, like Modesto. But this for a small business is a tremendous good resource. You can engage your team with some of that data that we showed you. You can even, if you want to, put a display out in the entryway and say, this is what we're doing, this is what it compares to last week, however you want to present it, and get people thinking about it, right? Same to your customers, either the display or in writing. You can compare to both standard ratings called energy use index for your kind of building, for your industry. And if you're better than that, you can tout that in terms of sustainability. Now, buildings over 50,000 square feet in California have to report their EUI and their Energy Star rating every 1 or 2 years, depending on the size. You can sign up for that, and that size rating is going down year by year. And in some cities like San Francisco, it's already down to, I think, 10 or 20,000 square feet that you have to report. So you can go on to the Energy Star site, create some sort of entry for your building, and you can find your Energy Star rating even if you don't have to report. It's interesting input. And then comparing that EUI. So I hope I didn't bore people. I hope I didn't dig too much down into the weeds. But again, what we wanted to do was just start people thinking about a normal building that you kind of don't believe that you can actually reduce usage in it, or it's just too annoying or too much of a pain to think about it. It's not true. You really can do some reduction.
Yeah.
And you're welcome to contact me if you want. And it's not a huge group, but any questions, I'm happy to answer.
I think the collection of information, it does definitely get you thinking. It's great information to hear. Yeah, and AI, you don't think of putting it in a place like this at this point, but totally makes sense.
Absolutely. Yeah, I mean, your thermostats here are the type that work with our system, just plug and play.
It's amazing. Oh, very cool. Well, Jolene, anything for you? You're muted still.
Nothing right now, but I just wanted to say thank you for your presentation. It's very interesting. You had a lot of details in there.
Thanks for inviting us, Jolene. We appreciate it.
Of course.
And in a couple of days, we'll have it rendered and we'll put it on our YouTube and on our website, and Jolene will let you know when it's out there.
That's great. Thank you.
Yeah, you're very welcome.
So goodbye to everybody who watches later as well.
Thank you. All right, Jolene.